Hello everybody. Today we're going over exercise 23.1 from page 777 from your textbook. And what this problem is looking at is the work needed or done by the electric force needed to move a charge from one point to another point. And we're going to find that if we draw this out, there's going to be a positive charge at the origin, and we're going to have this negative charge, let's call this Q1, and we'll call this negative charge Q2. And we're going to see that Q2 is going to be moved to this secondary point, and we want to know what the work is done by the electric force needed to move it to that point. Let me just label this. This is going to be RA, and this is going to be RB. And the reason why we need these radiuses is because when we're calculating the work from A to B, we're going to take a look at the potential energy at A, and we're going to subtract the potential energy at B. So this is an A. So let's give you some information here. So Q1 is going to be equal to positive 2.4 times 10 to the negative 6 coulombs, and Q2 is going to be equal to negative 4.3 times 10 to the negative 6 coulombs. And we're going to find that Q2 right here is, so let's just call this Q2 initial. The point that it's at is 0.15 meters in the x direction and 0 meters in the y direction. And Q2 final is going to be 0.25 meters in the x direction and 0.25 meters in the y direction. Okay, so R of A is going to be pretty simple. It's just 0.15 meters. 0.15 meters, and then R of B is going to be equal to the square root of the sum of the squares of both of these. So it's just 0.25 meters squared plus 0.25 meters squared. Okay, and we're going to find that this is equal to 0.3536 meters. These are threes. Okay, so now we're going to look at the potential energy at A and B. So the general form, the potential is going to be equal to K times Q1 times Q2 over R. So we're going to see that U of A and U sub A and U sub B, the only difference is going to be R. So if we look at potential at A, we're going to find that it's 9 times 10 to the 9th newtons per coulomb times 2.4 times 10 to the negative 6 coulombs times negative 4.3 times 10 to the negative 6 coulombs divided by R, which at A, it's going to be 0.15 meters. And we're going to find that this is equal to negative 0.6184 joules. Okay, so that was easy enough. Let's go ahead and move this down and so that we can calculate U of B. So U of B is almost going to be exactly the same thing besides the radius changing. So you can already start to think that the magnitude of this is going to be smaller because you're dividing by a larger number, which means that your work will probably be negative, or will be negative. Okay, so then we just divide by 0.3536 meters, and then U of B is then equal to negative 0.2623 joules. Okay, so then the work from A to B is simply equal to U of A minus U of B. So let's just plug the numbers right in. 0.6184 joules minus negative 0.2623 joules. And this is going to be equal to negative 0.356 joules. And this is the work done to move Q2 from the initial point to the final point.